In this case, it was an iterative approach. We would get some information together, we would share it amongst ourselves, come back, we would have debates. Usually you get, hey, this has worked for me in some other places. You zero in on those things. But we actually challenged ourselves to look at other things that we don't normally do.
We tested close to 70 ECMs, energy conservation measures, by modeling them against the energy consumption profile. And we only chose 8. Together, those 8 energy conservation measures, deployed in the building and in tenant spaces as we refit the building for new tenants, made the difference. 38.4% savings.
Historically, we've taken a look at windows and we say, they have a 20-year payback. There's no way it's going to work.
When you look at the size of the building and how many windows there are, it's a huge percent of the facade. I think everybody said, what? And then after we all looked at it, one by one, we all became believers, and now we're going to do it.
We're actually taking down 6,500 windows, refurbishing them, making them more energy efficient.
By changing the building envelope insulation, both through the windows and against the walls themselves, it lowers both the heat and cold loads on the building.
The way we as engineers like to look at it is what we call interactive effects. When we think about, well, the windows are going to do some good, well, yeah, they'll save energy, but more importantly, they'll make our system smaller. Our heating system is smaller, our cooling system is smaller. That optimization is much different than just what's the energy savings from a better window.
Integrated design was really important because it forced us to look not only at energy savings, but also at capital cost savings. If we had just looked at projects in isolation, we would not have come to that conclusion.
I'll give you a sense of the impact. As part of our program, we thought we're going to have to retrofit and upgrade the cooling of the building. We're going to have to add capacity. We actually have overcapacity in our cooling because we've reduced the heat load and we're managing the heat load better. So there's massive innovation here by looking at an integrated approach.
In a multi-tenant building, you have to think about the people who are going to live in the building. So one of the really exciting parts of the Empire State Building is the fact that the owner has decided to do some pre-builts that demonstrate that you can marry energy efficiency with ambiance. It's a way to very concretely convince tenants that they can reduce their carbon footprint, reduce their energy, water, heating needs, and at the same time have a very unique and interesting space.
We're going to be delivering the exact same work environment, in fact, perhaps a healthier, better work environment for far less energy consumption. And particularly in doing the project as part of a total comprehensive upgrade to the building, at any rate, 3-year payback.
What we found is that high-performance buildings aren't about adding a green covering at the tail end. That's always expensive, and that's what gives building owners and other folks in the building community the impression that green buildings are expensive.
What we try to do is look at all of these systems, how they fit together, and then see what elements are redundant and what can be eliminated.
We may spend more on insulation and windows, be able to make a smaller heating system, and then operate it at much lower costs over time. So that's the concept we call tunneling through the cost barrier.
We're so conditioned to thinking that very efficient must cost more, but through integrative design, you can tunnel through the cost barrier. At first, the cost goes up as you save more and more energy, and it goes up more and more steeply. That's called diminishing returns. But if you keep going, you often get to the point where you can eliminate mechanicals, for example, and then the cost comes down more than you paid to get there. And why should you get there the long way around when you can tunnel through the cost barrier directly to that destination?
The Willow School is a school for children in kindergarten through 8th grade. And it is a place that truly captures the essence of teaching and learning.
Honor. Let's see what honor is good at.
Our first building, which we built and completed in 2003, was the first LEED Gold independent school building in the country. And it was a real labor of love to build because in those days, no one was really talking about this, and the resources that you have today are just exponentially more available. The way we learned back in 2000, and we were lucky enough to have some very, very good mentors, was to do it in a way that may cost you a few extra dollars up front in the planning process, but saves a tremendous amount of money as you build the building. And that's the way we developed the whole campus.
But let's discuss the principles.
They were already in design development.
You could have a whole office.
Now, this is what I find fascinating, is that to Mark's credit, he said, stop the presses, we're going to revisit everything.
That would probably not be the smartest way to build a building.
So it was an education process that we took the time to do.
It's not only just a modeling issue, Stephen, it's also a comfort issue.
You're talking about a philosophical change in the way we look at things.
That's okay.
Rewind to 2002. We walked into our township with this concept of a green building and started talking to them about some of these concepts that helps mitigate and the pushback that we got. Oh, you can't do this. This can't be done. The town will never pass this. What kind of thermal loss are you talking about? Heat going out?
Yeah, versus your roof insulation.
And now, fast forward, and what we get now is tell us more instead of, go away.
One of the big drivers at Willow was the fact that they wanted to educate people on environmental, human health, sustainability issues, and frankly, what better way to do it than to actually walk your talk and do it in the development of your own building.
The buildings are teachers themselves. High academic scores are important, but knowing how to relate to people and to relate to your environment, how we take care of each other and this place has become a major emphasis in weaving our curriculum together.
In 2007, we completed our second building, which we built to LEED Platinum standards. The great thing about that building was we were able to build that building for $295 a square foot. We feel that that's moving into the realm of being able to build in the public school sector. So I think the education of everybody, from myself to our teachers, to our administrative staff, to the students, to our community, it's affected everybody. It truly has.
The entire site of the Springs Preserve is 180 acres. We developed about 30 acres in landscape around the buildings for the public use.
For the Springs Preserve to be a sustainable place, it wasn't so much that the buildings were platinum, LEED Platinum, which they are, 7 of them are. For us, sustainability includes all of that, but also has things about the people, the culture, the attitude, operations.
And that's the question.
Everybody was at the table talking at the beginning to look at a whole thing, not the traditional, there's a design, then there's a mechanical system, then there's a structural system. We had a team that was dealing with ecology, restoration, interpretation, exhibits. They were all there together.
It was really gratifying to bring all these people around the table and brainstorm sustainable principles where mechanical designers started with, what do we design a building with no mechanical systems? And it created a really dynamic synergy to philosophically push this into a building that performed at a high level.
There was a 22-acre flood detention basin that in the master planning process, everybody said, gee, why not use this as a potential for demonstration of what a native spring and wetlands would look like? Let's make it a demonstration facility.
The parking lots are covered with, I believe it's 2,200 solar panels that develop about 409 kilowatts of electricity. And that's about 2/3 of what it takes to run these facilities. The Desert Living Center shows these pieces and parts all working together as an integrated system where landscape is fused with building architecture, which is fused with mechanical systems, and then daylighting.
In the desert, there's a lot of light available all the time. There's a lot of heat available all the time. So really, the shading and the building form really was informed by that specific location, climate, and orientation. So it was aggressively, passively designed. That led to the need for a daylit building that really didn't have much electric lighting load.
We've cut our water consumption by about 65%. It still is a botanical garden, so we do use some water, but we also reclaim all of our wastewater, and then we run that water back into the buildings to flush toilets. So we have no sewage that leaves this site. There's 5 buildings in the Desert Living Center. All of them use cool towers. One of them has no mechanical systems at all. These are working laboratories where we can see which ones perform better at what times of the year and teach our greater community and other architects the abilities of what can be done with sustainable design now. The integrated design process was taken to another level on this project for us when we brought all these different components, civil engineers, mechanical engineers, electrical lighting engineers, day lighting experts. And I cannot imagine doing a building anymore without doing that.
One of my favorite Einstein quotes is the definition of insanity, right? Is doing the same thing over and over, but expecting different results. So if we expect buildings to perform significantly better, we need to change the process by which you put them together.
In a collaborative design process, you need to and you want to understand each other's disciplines.
One is we know that we need breakout space for this room.
Collaborative design is a lot more fun.
The integrative process asks us to understand that maybe rather than either or, we can achieve both and. That's when you know you're really on an integrative path.
When the whole team works on the whole building as an integrative design problem, you pay less and you get much better results. Everything gets better. There is no compromise, no trade-off.